Hello everyone, my name is Dr. S. Pavan Kumar Reddy, Assistant Professor in the Department of Artificial Intelligence and Data Science, B. Viraju Institute of Technology, Narsapur campus. I teach the subject is data structures using Python. In that subject, today we'll discuss about the one of the important topic in data structures is linked list. So I am follow the same textbook. The textbook is name is the Data Structures and Program Design using Python, the Malhotra. This is the topics under the linked list. Today we will discuss about the introduction about the linked list, single linked list, operations on a single linked list, merging the two single linked list into the one list, reversing the linked list, single linked list, advantages and disadvantages of the linked list, circular linked list and double linked list. Before going to the linked list, what is the list? Here, the list can be maintained in two ways. The list can be maintained in two ways. First one is arrays concept. Second one is linked list. Okay. The array start with 0, 1, 2, 3, 4. The linked list having the two parts. First part is the data. Second part is the address. Okay. Here, what is the definition of the linked list? The linked list is a linear collection of data elements. These elements is called as nodes, and also the key point of the node is to the next node. Here, the linked list is a data structure that can be implement the other data structures like stacks, queues and trees. Here, the linked list having the same manner in the another data structures that is the called as already discussed in previous classes, stacks, queues, and next we are covered the trees concept. Okay, in the same manner we are also implement the linked list. Here the linked list is a sequence of nodes which can be contain the one or more data fields. Okay, one or more data fields. Here the linked list is a sequence of nodes. The nodes having either one node or either two nodes. That means more than one or more nodes. It is a connected between the one node to another node. This is the example for linked list. Okay. Here already we discussed about the what is the linked list. The linked list having the two parts. First one is the data part and second part is the link part. The link part having the address of the next node, and also data have represent the actual data, having the actual data. See this example. This is the one of the best example for the linked list. The 5 is the data element, 10 is the data element, 15 is the data element, 20 is the data element, 25 is the data element. Here the linked list will be start with starting node and also end with ending. Okay. Here the 25 having the address is the null. What that meaning here? The 25 node is there in that last node in the linked list. This 25 having there is no extension of the another node. So it can be represented as a null or it is also represent the cross. Okay. Here the first element having the 5 and the second field is represented as the address of the next node. And also 10 is the data element. This one is the address or reference. This one is having the connected to the next node. So like that the linked list can be represented. Here the last node will be not having any next node is connected to it. It can be special as null. Already we will discuss in the previous slide. The last node can be represented in previous slide. The 25 is the node. The last node is not connected to the another node. So it can be represented as either null. The null can be defined by the -1. Okay. Here there is another special node that is called as start node. That already we will discuss in previous slide. The linked list having the start with start node. Okay. This one is the end node. Any node, one node is connected to the another node based on the reference of the first node. Okay. Here the start node can be represent the beginning of the linked list. The start node will be represent the beginning of the linked list, that can be represented as start equal to null. If the start is equal to null, the linked list is empty. If the start is null, the linked list is empty, because it cannot be defined the any node in that initial stage. Okay. A linked list is also known as self-referential data or self-referential structure. Okay, because each node point to another node that is as a same type. Because here, see this one. Here we are representing one node. The next node will be also represent the same node. So here the one node will be represented the first. The second node will be represented the same type of the nodes. That is the meaning of each node point to another node that is the same type. Here the linked list can be represented the two parts. First part is information of the first part contain the information or data. The second part is represent the address of the next node. Here in Python programming language, the node can be represented by using the class. How to define the class in that node? Here class node will be represented. Here def initialize the initialization function. In that parameter we are representing the self comma data. If self dot data equal to data, that is the link. First we are defining the node having the data. The next node, there is no next node na, so because we are representing the none. The linked list having the one node na. So this node having the two parts. The first part is represent the data. The second part is represent the address of the next node. Here in programming language, the node can be created by using the class. The node can be created by using the class. The class having defining the like this: class node def initialization. We are pass the two parameters self comma data. See this one. Here first we are defining the node. This one is the node. The node having the two parts. First part is the data part. Second part is the address part. Here we can pass the parameters na in that initialization function. First one is the self comma data. This data is known as this one. Okay, self dot data equal to some data, whatever the data is there, either 1, 2, 3, 4 like that. Whatever data will be available, that data will be pass the parameter. The second one is self dot next means first we are creating the single node na. So the node that not having the another node, that's why the self comma next equal to none. Self dot next equal to none. So there is no another node in that linked in that node. So we are representing this one is the null. The second one, we are linked with the one node to another node by using the linked list. Okay. Here we are defining the define the initialization self dot head equal to none. Self dot head equal to none. So this one is the head node. If the self dot head is equal to none means we are representing the linked list. Okay. So here there is some advantages and disadvantages in the linked list. So first we can see the advantages. The linked list is a dynamic data structure, as you will know. Here to go or sync during the execution of the program. The linked list have the efficient memory utilization. So here the memory is allocated whenever it can be required and deallocated whenever will be deleted. Okay. Here The main advantages of the linked list concept is we are inserting and deleting the elements is easier and efficient. Many complex applications can be easily carried the linked list. Okay. Advantages are there, but disadvantages are there. The disadvantages under the linked list is they can consume the more space because every node requires the additional node to store the address of the next node. The searching of the particular element in the list is difficult for time consuming process. Here, the linked list can be represented in representation of the single linked list is, see one of the best example. Suppose we have to store the list of the number 25, 54, 78, 90. So, how to define the node? The node is this one. First, initially we are creating the node having the represented the some address. 1000 is the address for this node. The data is 23, 54, 78, 90. Okay. The first data is 23. The 23 element having the some address. Okay. And also 23 have the some allocating the reference. This one is the 2000 reference. This reference is the next node. Next node. What is that next node? 54. The 54 address is 2000. The 54 having the some reference. This reference is known as the next node. The next node is 878. This address having the 3000. The 75 element having the third element, they had having the some reference. This reference is linked with the next node. That is the representation of the single linked list. Here, one of the question is how to access the first node in the linked list. How to access the first node in that linked list. The same previous example we are taking 23, 54, 78, 90. The address of the 23 is 1000, the address of the 54 is the 2000, address of the 78 is the 3000, 90 element address is 4000. The final solution is, what is the question? First node of the linked list. How to access? To access the first node of the linked list based on the header node. Head 1000 equal to 23. Okay, head 1000 equal to 23. Here we are representing the header node. Based on the header node, we can access the linked list. Here the linked list having the different types are there. What are the different types is single linked list, circular linked list, double linked list. What is the definition of the single linked list, double circular linked list and double linked list? See one by one the definition. The first one is the single linked list. The single linked list is the navigation is only forward only. This is the forward direction. What is the double linked list means? Forward and backward navigation is possible. Forward navigation and backward navigation. Okay. What is the circular linked list means? The circular linked list, the last element is linked with the first element. This is the nodes. Each node is connected to the another node. Okay. Circular linked list means the last node is connected to the first node, first element. This is the three types of the linked list. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.